record first, and then share my screen. So, okay. So, everybody can see my PowerPoint, right?
Yes.
Okay, great. Okay, today, this is what we are going to talk about. I don't want to give you some complicated concept, so I won't talk insulation tonight. Just talk about the HVAC and one question from the motors and drive. That's all about your lecture. I may. Oh, I maybe I opened the wrong PowerPoint. So give me a second. Yes, this better. Okay, that will be. Oh, not this one, sorry. Okay, anyway. Okay. This one should be. A moment, please. Sorry. Okay. Okay. So I share the screen again. Okay. Okay. So now everybody can see my screen, my PowerPoint. Okay. So if I haven't listened, I can't. So I keep going and talk about tonight's topic. And during the last lecture I joined together, we have heard one student mention about how we do the convention on COP and EER. Neither is SI unit or imperial unit. So today I also want to share how the convention make, because as I listen to Professor, and it seems he will have such similar questions about the convention of the unit. Let's see. So followed by COP and EER, I also give you two examples, but it's very easy. Just substitute the number. And finally, I will give one more example. This example, maybe all of you have listened to me, but I would like to review again, because I read your lecture notes in last Thursday. It mentioned something, the flow rate, speed of motor, pressure, square of speed equal to the proportional to the pressure, and creep of the speed of the motor is proportional to the power of the pump. So I would like to review this to you guys and make sure you understand why we need to have variable speed control or variable speed drive on the motor. Because if you can save 50% of the speed, then you can save 50% with creep to the power. Okay, so let's start. So first of all, you need to understand what is meant by the EER. Actually, EER is output thermal work over input electrical power. But one thing you need to bear in mind is the unit. In the SI unit, I believe all of you may quite familiar with the SI unit instead of the British thermal. That is, I recall the imperial unit, imperial, okay, British imperial. So British standard is imperial unit in other form of presentation. So for output thermal work, unit is the kilojoule over hour, okay, for the SI unit. And the input electrical power is kilowatt. It is very important because this unit difference is exactly what the variance between the COP and EER, okay? COP, both are the same. EER make difference. I repeat, as for SI unit, that is the kilojoule per hour for the output thermal work, no matter cooling or heating. Input electrical power, which we use the unit is kilowatt, okay? So it is a SI unit. For the imperial units, we will use BTU per hour, BTU per hour, that is the output thermal work. Here, I also mentioned a little bit more on the EQuest. If you need this software in the EQuest, somehow it may confusing you because in the EQuest, the unit representation is without this directly PTU or KPTU H. So bear in mind, if we talk about BTU, because BTU is a unit of energy, and over time series, that is the power. So in imperial unit for EER, output thermal work, we use BTU over hour. And the input electrical power, we use kilowatt, okay? Any question on that?
No, it's fine.
Okay, so fine, I skip a little bit. I just go to this area, and somehow if the question asks you to define the relationship between COP and EER, then you need to know the unit difference on EER. So we try to work out based on the unit reference and transform this ER to COP. And I would like to show you one slide more about COP. COP is the coefficient of performance. But the difference, again, the difference between COP and EER is the unit. They also represent the same thing, the output thermal, power over the electrical input power. But the unit is different. COP is kilowatt output, okay, or kilowatt hour. That's the energy. So try to remember this is kilowatt hour, kilowatt in. But EER is a kJ, kilojoule hour, kilowatt. Okay, so this difference or with this variance, we can first step to synchronize or to identify EER is kilojoule per that is a energy unit, kilojoule over the watt hour. So we also need to make the convention because if we want to have the kilowatt, we need to with this unit is different. So kilojoule, if we need to have the joule, then we need to multiply 1,000. And if we need to have a kilo, the watt hour to joule, we need to have a 3,600. That is on the unit of the hour. So we cross out all the unit, then we can obtain this relation. That is the SI unit. But of course, you can convert ER 3.6, that is 1 over 0.275, then that is a 3.6. On the other hand, if we are touched with the imperial unit, that is the PTU, we did the same. But the relationship between the Joule and the PTU is very close, but it's not 1,000, it's a 1,055. That is what is shown here. 1 kilojoule is equal to 1,055. So we also make such convention and we can obtain 3.412 COP is equal to 1 EEL. Okay? So that is the convention between two type of unit, imperial unit and SI unit, and also the COP to EER. Okay, any question on that?
We're good.
Okay, very good. If you still have a question, I will send the email to you about the video link and also this PowerPoint, and you can take a look on more detail on ER and SER. I believe you can also read the detail in your textbook, but for this, a simple sentence may make you more easier to understand or fast track to understand. ER is FH, performance, okay? And ER, the difference between ER and COP is the unit difference, okay? So if you can handle COP, ER, SER, or just COP and ER, I believe you can handle most of the questions in this HVAC, okay? So let's see some of the, that is also an example on to show you how the convention is just by sentence, every sentence to explain this equation. It's more clear and detailed on this. Okay, let's see one example. If the HVAC system that we move a heat in problem 8.1, you can refer to 8.1 about in your textbook, and has COP 2.0 and run continuously. How many kilowatt here will this load contribute to electrical peak if the peak usually occurred during the working days? So what this question is asking for is about the electrical input. So the electrical input, now we have the COP that is equal to 2.0, and make use of this equation, kilowatt heat removal. Remember, COP with the same unit, no matter it represents the thermal power or no matter heat or cold, and over the electrical power, also the kilowatt or watt, same unit. So COP without any unit. So I have two here, and the heat removal, the power, you can refer to 8.1, that is 7.15. Then we can easy to obtain 3.6. Okay. So, any question on 8.4?
No.
Okay, very good. So next one, same situation. When we handle this question right now, also a COP. COP may be a little bit more tricky because they have the same unit. But if this change to ER, maybe much easier for you guys because it will show you the difference unit. But now this question is COP. Right now is equal to 3.0. And the electrical, how many, the question is asking about the electrical input. The input in terms of the unit is an energy unit, kilowatt hour. Okay, so electrical input that I'm going to check by this equation, we are going to find this one, and it's given the COP. So also given the heat removal. Heat removal is 120 million kilowatt hour. So just putting number to the formula, then we can obtain the answer. Any question on this? Okay. So
the 100 million kilowatt or are they kilowatt cooling, right?
yes.
Okay.
Yes.
Oh, okay. Yes.
Okay. So if no question, we will jump to the final question. So this question I think is not appear one time, but I review the last lecture. You have talked about such equation, such relation between the speed, pressure, and power. So I would like to revise to you guys again, because it's also a very important concept, especially when you handle, I'm not sure, I would like to ask, when you handle your project, you need to do the presentation. Do you need to use the software EQuest or not?
No, he didn't mention about all of that software. I think we don't need to use any software.
Okay, no problem. So, but anyway, being in the future, being an engineer or the energy manager, and you're always thinking how to improve the energy utilization. And of course, you can do many things. Let's say if you're building with a high proportional space conditioning on the energy, so you can add the insulation, okay? But somehow, I'm not sure, you have heard some people will suggest, if I switch the motor from constant speed to the variable speed drive or variable speed control, it also can save energy. So that is related to these three equations. For some, let's say, for some building, they have the boiler. The boiler will heat up the water and use the pump to pump the hot water to heat exchanger. Let's say this example. In the cold weather, if you feel cold, you want to switch on your heater, and you also turn on your furnace, whatever. And so you need to have more hot water to flow through, and so you need to have more fluid, hot high temperature fluid, to go over the heat exchanger to do the heat exchange and make your room feel comfortable. Compare in the summer. In the summer, you don't need any more. But we also research some hot water for your take shower or bath, because it also needs the hot water in summer, but not as much as in winter. So if the motors constant speed, no matter what is the situation it is, the speed is constant, you will consume some more energy in summertime, because you need to make use of your valve to control the flow rate. But if the motor can adjust the speed and adjust the flow rate, the pump flow rate. So in this example, or in this formula, we can know that if we make the change on the flow, and the relationship between the flow and the pressure, if we make 10% decrease on the flow rate, then we will have a 10% square. That is 1.1 square 1.21 on the pressure difference. And for the power is in the creep relation. So if we can adjust the speed, we can save not only the proportion relation, is the proportion of the creep of the speed. That is what the power we can save. So let's look at this. Example. The question: a 10 kilowatt centrifugal fan is supplying 900 liters per second on a very hot day. So in a hot day, we still need to have the flow rate, or maybe here is on the air, the flow rate of the air. But on the cooler day, the VFD drops the fan speed down to where it supplies only 600 liters per second. So it seems like it's not a heating appliance. It's more like a cooling or ventilation appliance in this example. In a hot day, we need more way to make the room atmosphere with the more flow rate to drive the hot or high temperature air out. So it needs to have 900 liters per second. But on the cooler day in the winter, I don't need so much flow rate. I only need 600 liters per second only. So how many kilowatt of the fan motor supplying for new 600 liters per second? So here is, never mind, we can finish it. The flow and the speed is direct proportional. About the pressure and the speed is the speed square is equal to pressure. And about the flow or the speed related to the power is a creep. So now we know the flow and we are asking for obtain the power. So we make use of this equation, the creep, and then substitute the number over there, and we can obtain the power. So you can see that originally, meters per second, we need to have 10 kilowatt of the fan. I just make the adjustment on the speed from 900 to 600, but I save more than half power finally. So that is the power of the power of variable speed drive compared with the constant speed drive. Any question on this problem?
No, it's clear.
Okay, that's good. Okay, so I think I have finished all the things I would like to share with you today, and I will summarize this. First, we have talked about the relation between the EER and the COP, and also touch a little bit on SER. You should know about it because HVAC all the times they just tell you, or in the nameplate, there's an ER equal to watch. You should know what does that mean. No matter ER and the COP, it's with the same definition. That is the thermal work over the electrical power. The same definition, but the difference is the unit. For the ER, it's kilojoule per hour over kilowatt, or BTU over hour over kilowatt. But the COP, we have the same unit, kilowatt, kilowatt, kilowatt hour, the same. So you can try to do your own or the convention between COP and ER, neither in SI unit or imperial unit. Okay, and we have tried to very simple question about the COP, and also talk about the relationship between the speed, pressure, and power. So that is what I want to say and present today. Thank you very much. Welcome to all comment, question.
thank you. Thank you for
Thank you.
the summary.
Okay, so if any question, you are feel free to send an email to me or any sharing. I also welcome, especially when you want to take some courses and ask me advice. I know, or if I know, I also share my experience with you guys. Okay, have a great day, and I hope you all can have a very good result in the coming Thursday.
Thank you so
Okay.
much.
Thank you. Thank you. Okay. Have a great evening.
Thank you.
Thank you.